Okay, we have a situation where X stands for the number of units manufactured, let's say, and we're going to sell these units. The cost of manufacturing X units is 400 times X plus 50,000. You could say, well, it costs $50,000 to set up to do these, and then every unit we manufacture costs us $400 to produce. Okay, so the total cost of producing X number is this. The cost to actually produce the things plus the cost of setting up. Okay, the revenue we get is 1200X minus X squared. So, not going to explain that function at this point, but we'll look at revenue functions and see how that works. Okay, so the revenue, if you produce X items, is going to be this. Basically, if you produce too many, some of them aren't going to get sold, or the demand is going to be such that you have to sell them a little bit cheaper. Then we say that when X equals 100, if X equals 100, then X is increasing at a rate of 15 per month. That's a rate with respect to time of 15 per month. Okay, so when we're producing 100 of these, we're increasing our production at a rate of 15 units per month. Now, that statement means that dx dt is 15 per month because dx dt is the rate of change of X with respect to t. So dx dt is 15 per month. So what's the rate of change of our revenue? Our revenues are R of X function. Well, the revenue, the rate of change with respect to time, and let's put that in here, with respect to t of our revenue, that would be dr dt, derivative of revenue with respect to time. And that, by the chain rule, is equal to derivative of R with respect to X times the derivative of X with respect to t. The interpretation is dr dt, well, R is revenue, that's in dollars. Divide that by dt, you're dividing the number of dollars by the change in time, by the time that passes. And that is interpreted as the extra number of dollars per month in this case, because our time is going to be measured in months. Okay, dr dx is the extra amount, the extra number of dollars you get per unit. Okay, so if you're doing a delta R over delta X, you're getting the change in the amount of dollars, in the number of dollars you get, divided by the change in the number of units you produce. That's the extra money you get per unit. And dx dt is the extra number of units per month. That would be our 15 units per month. So the chain rule has a meaning here. Now, in calculating this, we calculate dr dt as dr dx times dx dt. We already know that dx dt is 15, standing for 15 units per month. And dr dx is what? Well, R is 1200x minus x squared. The derivative of that is 1200 minus 2x. And here it is, 1200 minus 2x. We multiply the number of, and again, that dr dx is the number of dollars per unit. We multiply that by the number of units per month, okay, and we get the number of extra dollars per month. And that would be this quantity here. And I should say this is the extra dollars per unit here. Okay, there's the interpretation. Now, they're asked also to do the same thing for C of X for the cost, but the analysis for the cost would be actually even simpler because your derivative is quite simple here. Your derivative is just 400, and you're going to multiply that by your dx dt, your 15 per month. You're going to get 400 times 15, 6,000, meaning that your cost is going to be increasing at $6,000 per month, whereas your revenue is increasing at $18,000, but minus 30x dollars per month. Now, when X is 100, 30x is 3,000. So you still have $15,000 per month of extra revenue against that $6,000 per month of extra cost. You're still making money. You still want to increase your production. So there are all kinds of interpretations around these, but the mechanics of applying the chain rule are fairly straightforward. Okay? So we will be dealing in the third chapter of this applied calculus course with a more sophisticated or more detailed analysis of just what these rate and cost functions mean. Okay, this technique will be very handy when we do that. And these interpretations will become more and more clear with additional examples.